Hello everyone. Till now we are solving the sliding window problems in this series, and this is the last problem of the series. The problem is minimum window substring problem. So till now we have solved the problems like longest substring problem to find the longest substring or to count the number of subarrays. But today's problem is different, and this changes the sliding window logic. So first of all, let's just read the problem statement and then we will move forward. So the problem is about minimum window substring problem. The problem statement is that we are given with two strings s and t, and we have to find the minimum window substring out of the s string such that every character in t, including the duplicates, is included in the window. So what this problem statement says is that we will be given with the two strings s and t, and we have to find the minimum window substring of that s string. So one s string will be there, as you can see in this example. S string is there and we are having t string. So we have to find that minimum substring from this s string, and in that particular substring all the characters from t string must be there, and not only all the characters from t string but also the characters along with their correct frequencies. For example, if a is present one time here, then in that substring a should be coming one time, b for one time and c for one time. Let's say if a was present in this t string two times, then in that particular substring it should also contain it should also be there two times. So that's what it means. So we have to just get a minimum window substring from this s string, and that particular substring should contain all the characters of this t string along with their correct frequencies. And once we get that particular substring, we have to return that. But that should be minimum window substring. Means there can be multiple substrings which can be there, which will be containing a, b, and c. But we have to get that minimum window. For example, in this substring, we can see that b, a, and c is the substring which is the minimum window substring. This one. Like there can be another substrings as well in this. Like here is b, here is a, here b, here c. So this particular substring can also be a part of that, but it is not minimum. So the smallest substring we got of the S that contains A, B, and C is B, A, and C. This last one. Okay. This is the example we have seen to understand this problem statement. And another example is this, that we are having S string which contains of the character A, and T string which consists of two characters, that is double A. Now we want a substring from this S, minimum window substring, that contains all the characters. But because only one character is present in this S and T string contains two characters, so therefore we can say that because we need two A's but it only consists one character in S, so therefore we cannot get that minimum window substring and we will have to return empty in that case. And it is also mentioned here that if there is no substring present, then we have to just return an empty string. Okay, so this is the problem statement we have seen. Now one thing I want to tell here is that whenever we get such kind of problems like where we have the substring or the subarray, so we can just think of the sliding window approach, that okay, we can solve this with the help of sliding window. But first question which should come in our mind, that okay, if this is the problem, means if this is the one type of problem, then what is the goal of this problem? For example, we have solved multiple problems in the sliding window pattern in this series. So for example, we have solved for the longest substring. So there we get to know that okay, we have to get the longest substring, so we have to expand our window in order to get the optimized result. So we have to maximize the things here. Okay, and in the case of count subarrays problem, we have to simply count the number of subarrays. That was our goal. In the exactly k problem, what we did was that in order to solve it, we just transformed the problem. Like we solved that AtMost K problem, and eventually we came to know that okay, exactly k problem can also be solved. So that was the goal, to transform the problem. Now this problem is about minimum window in order to get the smallest valid window. So what the goal we are having, that we have to minimize the window, or we can say that whenever we get a particular window valid, so we know that okay, we got a valid window in which all the characters are coming from T string in this S string. Now we can try to minimize it so that we can have an optimized result. So this is very important, that whenever we get a particular problem, we should understand that what is the goal of this problem. Like in longest substring, we have to maximize. In count subarrays, we have to count. In this minimum valid window, we have to get the smallest valid window. We have to minimize the things. So this is our goal. I have to just give an important insight here, that when we have solved the problem for this longest substring, what we did was that whenever a window became valid, what we did there, let's say we are having a window valid. Okay, And once the window became valid, now we want the longest substring. So once the window is valid, we then try to expand it. So that we can have a more better result, a bigger result. So that's what we did there. But this problem is about getting the minimum valid window. So whenever we get a window valid, in this case, what we will be doing is that we will be shrinking that particular window. Once we get the valid window, then we try to shrink that window. Okay, so that we can get the more optimized result. Because in longest substring, we have to get the longer substring. So we maximized the result and we expanded it. And because in this minimum window, we want the smallest valid window. So what we will be doing, we will be shrinking that particular window when it becomes valid. That's what we will be doing. So now a small brief that we have seen in this problem statement, that whenever we are having like when we have to get a minimum window substring in S, we have to not just see that all the characters from the T string, but also with their correct frequency count. For example, let me just take a simple example. Let's say we are having one string S and another string we are having T. Okay. Now there can be any S string, and let's just say that we are having this T string which is AABC. Okay, and now let's just see the count of both, like all the characters. So A is coming here 2 times, here B is coming for 1 time, and here C is coming for 1 time. Okay, so what we can see from here, that we don't like, see, whatever can be the S string. Now we want a minimum window substring, or a substring in that S, which contains all the characters of this T string. But I'm not only saying that I want A, B, and C in that particular substring, but I also want to ensure that whatever the count or the frequency of these characters is present in this T string, that should also be validated. Means if A is coming 2 times, then in that substring A should come 2 times. If B is coming 1 time, B should come in that substring for 1 time. If C is coming for 1 time, then it should also come in that as substring for 1 time. So that's what the case here. So whatever the frequency count of all the characters is there in the T string, that should be that particular requirement must be satisfied. Then only we can say that the window is valid. So this is the case which I want to just tell here. Now for this, what we will have to do is, obviously we are having two strings, and now we will have to keep these characters stored somewhere. So we will be using two maps here. Okay, we will be using two maps. One map will be the need map. What will be the need map? Need map will be responsible for storing the characters from the T string. Means all the characters from the T string along with their frequency count, that will be stored inside the need map. And another map we will be using will be the window map. Okay, what will be the window map responsible for? Window map will be responsible for storing the characters which are along with their frequency count, which are present in the current window, or we can say at the time when we will be traversing on the string S. Okay, so whatever the current window we are maintaining, that the count of those characters along with their frequencies, okay, the frequency of those along with their frequencies of those characters, that will be stored inside the window map. So these are the two maps we will be using. One is the need map, and another is the window map. But see, because we want that minimum window substring, and in order to get that minimum window substring, obviously we will have to compare the both of the maps again and again. But that will become somewhat complex, and in order to remove this complexity, instead of comparing these two maps again and again in order to get the minimum window substring, we can simply use two variables. One variable we will be using is the required variable. Required variable will be having the number of unique characters. Let me just write it. Number of unique characters in the string T. Okay, so required variable will be maintaining the number of unique characters in the string T. And another variable we will be using is the formed variable. Formed variable will be the number of unique characters, or we can say number of characters whose frequency requirement is satisfied. Okay, now let me just explain what it is saying. See, if we will be comparing these both of the maps, obviously we will have to compare at the very naive thinking. If we think, then we will have to compare these both of the maps in order to get those characters of the string t in that particular substring. But again and again comparing these maps will become very complex, and instead of comparing these two maps again and again, we can just use two variables. One is the required variable and another is the formed variable. Where required variable is storing the number of unique characters in the string t. See, if we are having this t string, and we know that these a is coming two times, b is coming one time, and c is coming one time, but what are the unique characters? Unique characters are a, b, and c. So that number of unique characters will be stored in the required variable, and formed variable will be maintaining means out of those unique characters which are present in the t string, how many characters are there whose frequency requirement is satisfied. For example, if we got a window where a frequency is 2 and that frequency requirement is satisfied, then formed will be having that one character whose frequency requirement is satisfied. Now what is the conclusion we can make out from here? See, required is containing the number of unique characters in the string t, and formed variable is containing the means out of those unique characters, how many characters are there whose frequency requirement is satisfied. So once these required and formed, when they becomes equal, what we can make the conclusion from here? But once these required and formed becomes equal, then we can say that we got a window valid. Again, let me just explain once again. We are having required variable which is having the number of unique characters in string t. Okay, all the unique characters. Let's say t string is having abc. Now formed is having number of characters whose frequency requirement is satisfied, means out of those unique characters which are present in the string t, how many characters are there whose frequency requirement is satisfied. So if this required is having 3 unique characters, and once we get to know that okay, formed has also become 3, that all the three unique characters frequency requirement has been satisfied, at that point we can say that required and formed are equal, and once these are equal, we can say that we got a window valid. At that point we can say that we got a valid window. Okay, and once this valid window we got, then what we try to do, we then try to shrink that particular window to get the optimized result. So what is the pattern we are seeing here? It will be like, for example, obviously we are having the invalid window at the start. So at the start we are having an invalid window, and now what we will have to do, we will have to expand it in order to make it valid. Okay, so let's say we just expanded right now, still we are having invalid window, so we again expanded the window, still we are having invalid, so we are again expanded the window. Right now we saw that okay, we got the valid window. Okay, we can see that we got a valid window. We saw that we got a valid window, and the moment we got a valid window, now because we want the optimized result, we want the minimized result, so we will then start to shrink it, again shrink it, and let's suppose at this point we got again a invalid window. Okay, this is the invalid window, then again we try to expand it. So this is how the process will move on, and till the end, when we are till the point we are getting the minimum valid window, we will just continue this particular thing based on our logic. So this is some concept which I have just explained here, and now to understand it in more depth, let's just perform a dry run on the example which we have seen in the problem statement earlier. So this is the example which we have seen here, the first example. Now we are going to perform a dry run on this. So this is the example which I have taken. Now as I have just told that we are going to use two maps. So let me just take two maps. One map is this. Let's name it as need map. One is this map, and another map is a window map. This window map. Okay, so we have taken two maps. Now what I told that in the need map, we will be storing the characters which are in the t string along with their frequency count. So in the t string, we can see that ABC which are present for one time each. So we can just take these characters with their frequency counts. A is present in this for one time, B is present for one time, and character C is present for one time as well. Now we are having this need map. Now let's start with this S string, and as we move forward, whatever the current window we will be having, those characters along with their frequency count will be stored inside this window map. and we will later check that how we are using those two variables in order to have have that substring, get that substring. So we just taken the two maps. Now I have also told that we will be taking the two variables. One is the required variable and another will be the formed variable. So initially the required variable will be containing the number of all the unique characters from the T string. So we can see in the T string all the unique characters are 3. So this will be containing 3 at the start. And another variable will be the formed variable. Formed variable will be whatever means out of those 3 characters, the unique characters from the T string, out of those, what are the characters whose frequency requirement is already satisfied. So that number will be stored here, but that will be incremented eventually whenever we get to know that okay, we got a particular character whose frequency requirement is satisfied. So initially it will be 0 right now. Okay, and whenever the characters start to satisfy their requirements, then we can just increment that formed variable. Now we know another thing, that we are going to solve a problem for minimum window substring. So we want a minimum valid window, and for that we will have to take the minimum length every time, and that I am just initializing it with int max at the start, and whenever we get a minimum valid window, then we can just update it. And because we have to return the substring here, so we have to just take the start variable so that we can have a start point, means whenever we get a valid window, so that we can just take that left pointer of that particular window and put it inside the start, so that we can have a memory that okay, this is the particular starting point where our valid window was started, and whenever we get to know that okay, this is the window, and at the end when we are returning, we can just use this start in order to get that substring or returning that substring. So at the start I'm just initializing it with 0. Okay, now let's start. Now we know that at the start the window is invalid, so we can just start one by one from the s string and start to use these two variables in order to get that substring. So we will just expand this window with the help of right pointer. So this right pointer is present at this starting index. So right now this character A is there, and we will just take it and put it inside our window map right now. So A character is here, and we just put it inside the window map along with its frequency count, that is for 1. Now what is the next step? We have taken this particular character here, and now we will have to check if, first of all, we have to check if it is present inside the need map or not. Okay, need map means in the sense that if it is present inside the T character, a T string or not. So now we can see that A character is present inside the T string, and once we get to know that okay, it is present inside the T string or in the need map, then we will check if the frequency count of both of these characters are matching or not. And if they are matching, then we are sure that one of the characters is there in this particular s string or in this window, current window, whose frequency count is matching, means that character is present for one time in this s string. So because both are present for one time, so what we can do, that we can just increment this formed count. What is formed, I have already told that it is responsible for representing the number of characters whose frequency requirement is already satisfied. So we can see that one of the characters frequency requirement is satisfied here, so therefore we can increment this formed count. Okay, and once it becomes incremented, at the very next step we have to check if these required and formed are equal. At this point of time these both are not equal, so therefore we have not got a valid window. So now because these required and formed are not equal, so we can just take our right pointer and move it forward. So a right pointer came here. Now again another character D. Now let's just take this D character inside this window map. So again it comes for one time. Now again the same step. First of all we have to check if it is present inside the T string or not with the help of need map. So we can see that D is not present in this need map. Therefore it is not present inside the T string. So we do not have to do anything in that case. Simple thing is we have to take this right pointer and move it ahead. Again O, which is not, we have to firstly take inside the window map. Okay, So this we have taken. Now again we checked inside the need map, it is not present, so we do not have to do anything. Now right pointer moves ahead. Now it is pointing at the character B. We taken this character B inside this window map, and first of all just check if it is present inside the need map or not. So we can see clearly that B is present inside this need map, and it means it is present inside the T string. Now next step, firstly we check this that if it is present or not, and then as part of the second condition we are checking what is the count of this, like if the frequency count is matching or not. So B is present one time, B is present one time in both of these need map and the window map. So therefore one of this another character is B whose frequency requirement is satisfied out of those unique characters. So we can again increment this formed to 1, that will now become 2. Okay, again are these formed and required equal? No, these are not equal, so therefore we still not having any valid window. Now again take this right pointer and move it ahead. Again we got another character, that is E character, and we can see here that it is not present inside the need map, so no need to do anything. Now this right pointer moves ahead and we got a character C. Now the C character came inside this window map, and again now we check inside this window in this need map if it is present or not. So yes, we can see that C character is present in the T string in the need map as well. So therefore now we can check for the second condition if the count are equal. So yes, we can see that the C is present one time in each need map and the window map. So again we got another unique character whose frequency requirement is satisfied. So we can just increment this form to 3. Okay, so now what you can see, now you can understand more clearly from here. This required is telling that the number of unique characters which are present in the T string, and formed tells that out of those all the unique characters, what are the number of characters whose frequency requirement is satisfied. So there were 3 unique characters in the T string, and out of those 3 unique characters, all characters frequency requirement has been satisfied till here. So what we can see here, that whatever the number of characters were their unique characters in T, all their frequency requirement has been satisfied in this particular window. So therefore we can see that this is one window we can see here which contains all the characters of the T string along with their exact frequency counts. Okay, this is one string we can see here, and that is a valid window, because what we told that required and formed, whenever they becomes equal, we got a valid window. So right now we got a valid window, and once this window becomes valid, what is the next step? I have already told. Once any window becomes valid, then we have to try to shrink that particular window. And how we shrink any of the window, we have seen in the previous problems as well. We shrink that particular window with the help of left pointer. So now let's try to shrink this. But before shrinking, first we already know that this is a valid window. So first of all, we will have to update its length. How we will update its length? Right minus left plus 1, as already told in the formula in the previous videos as well. So right minus left plus 1, that will be 5 minus 0 plus 1, that will be 6. So minimum length we will be updating right now for this valid window will be 6. Okay, and also one important point, we have taken this start. So once we got this valid window, we can just take its left pointer and update it inside the start, so that we can remember later that okay, we have got one valid window earlier whose starting point was this one, left pointer. Okay, so we can just take that left here. So where is left pointing right now? At 0. So we can just update it with 0. Now let's start shrinking it. So right now this left pointer is pointing at this character A. So first of all, the character A's frequency count will be decremented from this window map. So we can see here once the frequency count is being decremented for this character A, it will now become 0. We also have to check, as we checked earlier, that if this character is present inside the T string or not. So yes, it is present, as we can see from the need map. And then as part of the second condition, we will be checking if the frequency count is matching. So right now the frequency count is not matching. It means this is one of the character whose frequency count is not matching. So therefore, what is the form representing? The number of characters whose frequency requirement is satisfied. One of the characters frequency count is not satisfied. So therefore we will have to decrement this formed here. The important case here. Okay, we have decremented this formed, and once we decremented this formed, now we can take this left pointer and move it forward. Okay, this is the left pointer, and let's just move it forward. Now this is pointing at the another character D. So what we can see from here, that this window now became this part. Now, are these formed? Now again check that particular condition. Are these formed and required equal? Means you can see here 3 and 2 are not equal. It means that particular window is not valid, and you can also visualize from here. It is containing B and C, but it is not containing A. So therefore this window became invalid. And once it became invalid, what I told you, that once any window became invalid, we have to expand it again. Okay, and that will happen with the help of right pointer only. So first of all, this right pointer will move forward. Okay, and now it is containing the character O. So let me just take this window map and okay, so we can just increment the count in this, and we are already having the O character in this, so we can just increment its count, and it now becomes 2. Okay, now this we will just check if this character is present. So it is not present, and we can just move forward with this right pointer. This right pointer moves ahead. Now another character comes D. D character is also already present in this, so we can just increment the count of it, and again check if it is present inside the need map or not. So it is not present, we can just move forward. Okay, so we can just move forward from here. Now comes the another character D, sorry, E. So E is also already present, so we can just increment the count of it, and again check, or because it is not present, so we can just move this right pointer ahead. And then comes to the another character, that is B. So B is also present, and we can just increment the count. Now again we will check if it is present inside the need map or not. So we can see that the B character is present inside the need map. Okay, this is for one time. So first of all, we checked with the one condition that if it is present or not, and once it is confirmed that yes, it is present, then we will be checking if its frequency requirement is satisfied or not. Now we can see here that B character is present for 2 times in the current window, but we want only for 1 time. So it means we cannot say that the frequency requirement is satisfied. So therefore we will not be incrementing this formed, and because this required and formed are not equal, so right now the window is not valid. Still it is still invalid. Now simple thing we have to do, we have to just take this right pointer and move it ahead, and now it points to the character A. Now character A is already present, so we can just take this character and increment its count, so it now becomes 1. Now again check if it is present inside the need map or not. So it is present right now in the need map, and also with the correct frequency count. So frequency count is also matching. So what we can see from here, that okay, one of the characters frequency count is matching here, so we can just take this formed and increment it. So right now it becomes 3. Now we can see that the formed and required both are equal. It means whatever the unique characters were there in the string T, those all requirements are satisfied. Okay, right now. So here we can see that A is present for 1 time, B is present for at least 1 time, C is present for 1 time. So therefore the requirements are satisfied, and therefore what we can say that this is the valid window again. So let me just expand this. So this is a valid window we got right now, and now because this window is valid, so we will now try to shrink this, but before that we will have to update its minimum length. But because it is not minimum than the previous one, we will not be updating in the minimum length, and also the start will not be updated. So right now let's just shrink this particular window. Here the left pointer is pointing at the D character. So first of all, this frequency of this D character will be decremented by 1. So first of all, this will be decremented by 1, and this will now become 1. Okay, now because it is not present inside the need map, so no need to do anything. Just take this left pointer and move it ahead. Now here comes another character O. The frequency of this O character will be decremented, and it will now become 1. Okay, and it is also not present inside the need map, so just take it and move it ahead. Now this B character is present, so now the B character's frequency will be decremented, and it will now become 1. And again it will be checked if it is present inside the need map. So yes, it is present inside the need map, and is the frequency requirement satisfied? So yes, both are present for 1 time, so frequency requirement is satisfied. Nothing we have to do with the formed. in the case if this particular Windows map character whatever is there, if it is present inside the need map and then its frequency is lesser than, then we have to decrement the formed as we have done earlier. So right now the frequencies are matching, so we do not have to do anything. We just have to take this left pointer and move ahead. Now this E character is coming, so just decrement the frequency count of this. So it will now become 1. Again, it is not present inside the need map. Take this left pointer and move it ahead. Now the character C, so character C's frequency will be decremented and it will now become 0. It is present inside the need map, but as I have told, its frequency count of this character C inside the window map and the current window, it is lesser than the required one. So because it is lesser than, it means the frequency requirement is not satisfying. So we can just take this formed and decrement it by 1. That will now become 2. So this left pointer moves ahead. And now here we can see that the window became invalid. Okay, because required and formed are not equal. So we can see that A is present, B is present, but C is not present. So still we can see that the window is invalid. Now we will have to expand it in order to make it valid again. So right now this right pointer will move ahead from here, and it will now see another character, that is N. So the N character is not present, so we will have to take it here and with its frequency count. Now first of all, just check if it is present inside the need map. No, it is not present, so no need to do anything. Let's just increment this. Take the right pointer ahead. This is the C character, and again the frequency count of the C character will be incremented and will now become 1. Now just check if it is present inside the need map. So yes, it is present, and also the frequency count of both are equal. So we can just increment this formed. It will now become 3. Now because the required and formed both are equal, so again we got a valid window. The valid window we got. Okay, and because it is a valid one, so we will have to optimize it, minimize it. For that we will have to shrink this particular window with the help of left pointer. The left pointer is right now pointing at this O character. First of all, its frequency will be decremented by 1. That will become 0. And yes, if you see in the need map, you will not get O character. No need to do anything. Just take this left pointer ahead. Now another character D, nothing to do with this. Just decrement this count. Also, it is not present inside the need map, so no need to do anything. Just move this left pointer ahead, and once this left pointer moves ahead, now you will check. See, one thing which I just forgot to mention here, which is very core part of this problem, that should be updated again and again. So whenever this left pointer is moved ahead, now you check that okay, right now this required and formed are equal. It means the window is valid right now. So you have to update this minimum length and start at every point of time, because that is the core part. So right now this window is valid, so you can just update the minimum length with this formula, right minus left plus 1, and that you can see the length will be 5 in this case. Minimum length updated 1. If it is minimum, then update. And start will be updated with the left, that is currently pointing at index 8. And then you will do the rest of the things, like it is right now it is pointing at E character, so just decrement the frequency count of this E, and because it is not present inside the need map, so you can just move ahead. So you can just take this left pointer and move ahead. Now again, when you move ahead, again you check the required and formed, because the right and left and this required and formed are equal. So you can see that okay, again the window is valid. So again update the minimum length. If it is smaller than the previous one, then update it. So right now the updated one will be 4. It will be 4, and now the start pointer will be pointing at this left, where the left is pointing, that is 9th index. So right now the window is valid, and that window is valid whose length is 4, and it is starting from the 9th index and ending till 12th index. This is the updated one. Now again, what you will do, you will decrement this particular frequency count of this B character. So B character's frequency count will be decremented, and it will now become 0. And again you check inside the need map, because it is present and its frequency count is lesser than the required one. So again, what you can see, that the requirement is not satisfied, frequency requirement is not satisfied, so you can decrement this formed. And after decrement this formed variable, now you will be updating this taking this left pointer ahead. Now again, because this window is invalid, so we will have to again expand this particular window with the help of right pointer. And once this right pointer moves ahead, in this case, now the window becomes invalid completely, because there is no boundary of this particular window. Once we end this particular process, we get to know that okay, we are having a particular substring which is starting from 9th index, and the minimum length which is taking is 4. So starting from 9th index, it is taking the minimum length of 4. So it is clearly visually it is understandable that this particular substring is the result. Okay, how we are getting with this help of two variables. Start pointer, which is pointing at this ninth index, it is this, and starting from here go till four length, complete till 4 length. That will be the minimum window substring which we got. So that's how what we will be returning in this case, p a n c p a n c. This will be the substring or the minimum window substring which we got as a result. Now let's just go ahead and implement this. So this is the problem which we have just seen, and now let's just implement it. So first of all, let's just take this unordered map here. Unordered map. Two maps will be there. See, first of all, the character first parameter will be the character, and second will be the integer. So one map we will be taking, that is the need map, and the second will be the window map. And now let's just take the left and the right pointer. So left will be pointing at the 0th index, and right will be also pointing at the 0th index. Okay, and once we take it, now one minimum length variable will be there, which will be initialized with int max right now, and the second will be the start variable, which will be initialized with 0 initially. Now here we will have to take the while loop, which will be running until this right pointer is less than equal to s dot size. Okay, and obviously we have seen that once it moves forward or ahead of this, then that window becomes invalid completely. Now here we can just what we have to do initially, obviously the window is invalid, so we have to expand that particular window, and for that we just take the window map. Okay, but before that, what we have just forgot is that first of all we have to take those two variables. One is the unordered, one is the required and one is the formed. But before that, in the need map, we will have to store all those characters along with their frequencies. So for auto, ch for representing that character, and from the s string, from t string we will be taking. And what we will be doing is we will just take that need map, and for every character we can just increment its frequency. Okay, so that we can have all the characters with their correct frequencies. And now we can just take the two variables required, which will be having this need map dot size. Okay, obviously that will be having the unique characters from the string t, so that will be stored inside the required variable. And one will be the formed variable, which will be initially started just initialized with 0, and later on it will get incremented. Now here we will be expanding this particular window with the help of this. So s of right plus plus. Okay, with this help with the help of this, we can just expand our window. And once we just, let's say we have just put it one character inside that window map, now what we will be doing, we will just check if it is present inside the need map or not. So for that we can just use this count method, need map dot count. If that s of string s of right is present, okay, if that s of right is present, that will return true in this case. And once it is done, then we can, as part of the second condition, which as I have told, then we will be checking if the frequency count of both are equal or not. So you can just check with the help of this window map of s of right, if it is equal to need map of s of right. Okay, with the help of this we can check that condition, and if it is true, if both of the conditions are true, then we can just increment this form. What does it tell? It means that one of the frequency count of the one of the characters frequency count or the frequency requirement is satisfied. And once it is done, then we will just run a loop, or we can just put a loop while that till the point this formed or see. We can do one thing here to understand that whenever we increment this count of this formed, after that we have to check a condition that if the required and formed both are equal or not. And you already know that whenever these required and formed both becomes equal, at that point the window becomes valid. And the moment window becomes valid, then we have to shrink it. and we have to shrink till the point where it becomes again invalid. Okay, and because whenever we will be shrinking this particular window till the point it becomes invalid, that will be a repeated process that we have to follow, or that we have to do. Okay, some sort of same steps we have to run. So for that we will be using the while loop, where we will be checking the condition if this formed is equal to the required. Okay. And the till the point where this formed and required will be equal, till that point this particular while loop will run. And the moment they becomes not equal, means the window becomes invalid, then we have to again expand it. And for that, for again expanding that, we have to increment the right pointer. We have to move ahead the right pointer. Okay, that we have to do. So right now, just consider that invalid is the invalid window is there. You expanded it. Okay, formed is incremented, but that is not true. Window is invalid. Again, you expanded the window. So right now that is happening. But the moment it becomes equal, the window becomes invalid, and the window becomes valid. Then we have to shrink it. So this is for the shrinking part. Let me just write here. Shrinking the window. Okay. Now, what is the logic to shrink the window? See, first of all, whenever the window becomes equal, whenever the window becomes valid, then first of all we have to check if that length is minimum or not. So if right minus left plus 1, if it is less than the minimum length, the previous length which is updated, if it is less, then just come here and update here. That minimum length will be updated in this case with this right minus left plus 1, and also that start pointer, the help of that left pointer. And once this is done, then we have to try shrinking this window. Just take this window map with that s of left and decrement it. And once it is decremented, then again check if that is present inside the need map or not. Need map dot count and check for this s of left. If it is present, then you check for what, as we have seen in the try run. Whenever if that particular character is present inside the need map, means in the t string, then you check if the character which is present inside the current window, if its frequency is lesser than the expected or the required frequency inside the need map. If it is lesser, okay, check for that, like window map of s of left. If it is less than the need map of s of left, then what is our responsibility? Our responsibility is to decrement the formed count, because formed is saying that formed is representing the number of characters whose frequency requirement is satisfied. But here when you get to know that one of the frequency count of the one of the character is not satisfied, so just decrement that count. That is what we have to do here. And once we did that, then just take this left pointer and move it ahead. Okay, we have done our work. We have decremented the frequency count. We have decremented the formed variable. And once we did that, then just take this left pointer ahead. That's how we have to do here. And once all these things are done, at the end, what we have to do, we have to return what? See, first of all, we have to check if this, what we have taken this minimum length is equal to int max. And still, like this second example, as we have saw for the, not second example, third example, we saw that if the substring is not present, then in that case, we have to return the empty substring. So just check if the minimum length, the min length is still int max, means it is not updated yet. So you have to return empty string in that case, empty substring. Okay. Otherwise, no problem. We have to return the substring itself. So how will you return the substring? That will be returned with the help of these minimum and the start. Whatever is the start from there and go till minimum length. That will be the substring. Now, obviously, the substring will be coming from s string only. So s dot substr in this method, and start from this start and go till min length. Okay, and whatever will be the substring, that will be returned in this case. So let's just run this particular code. Let's just see if it works or not. Yes, it is working, and let us submit this. Yes, it is working. So now let's talk about the time complexity and the space complexity. So first of all, let's just see the time complexity here. So let's just talk about the time complexity. Okay. So here in the code, let's just see here. Okay, so now we can see here is that we are using this for loop in order to build the need map, and that is with the help of t string. So here we know that the length of this t string is n in this case. So in order to build this need map, here it takes O of n. So let's just write here for the time complexity to build a need map with the help of t string. It takes O of n. Okay. Now second thing is that in order to expand this particular window, we are using this right and the left pointers here, and inside this while loop what happens is that this right pointer and left pointer, they are both of the pointers are moving forward. Okay, right pointer is moving forward in order to expand, and when the shrinking happens, left pointer does not go backward, it also moves forward. So therefore we cannot say that it takes O of m square, because this we are running on this s string, okay, that is which is having the length m. So we cannot say that it is O of m square, but because this right and the left pointer both are moving in the forward direction, and every character is we can say is traversed at most 2 times, so we can say that it is having overall O of m time complexity. It takes overall O of m because both are moving in the forward direction. So in that sense, to like with the help of with left and the right pointers, with left and right pointers, we can say it takes O of m. So overall it takes O of m plus n. Okay, this is the time complexity. We have seen that both of the characters, like first of all, that need map which we are building, that will be taking O of n, and O of m will be taken that as both of the left and right pointers will be moving forward. So every character will be traversed at most twice, like once by the left pointer and once by the right pointer. So that is like O of m. So that is overall O of n plus m. That is the time complexity we have seen. Now let's talk about the space complexity here, and which is very important to understand here about the space complexity. Space complexity is something where the optimization is done. Means the time complexity will be O of m plus n only. It cannot be optimized from this, but space complexity we can optimize here. So let's just talk about the two approaches. See, in this space complexity, first of all, what we did was we just taken the two maps, and one is the need map, one is the window map. Okay, so need map is used here in order to store the characters of string t. Okay, and what is the length of this string t? That is we can say whatever is the length of this string t, that will be O of unique characters only. Obviously when it will be stored inside the need map, that will be the unique characters of t. Okay, so unique characters of t. Okay, that will be the space taken inside the need map. Now talking about the window map. So when I am talking about the window map, I am having two approaches. One is the general approach. Okay, one is the general approach, and second one is the optimized approach. Now let's talk about both. So the general approach which I am saying, whatever we have solved till now, we have solved with the help of general approach. How? Let me explain it. So here what we did was, inside the window map we were storing all the characters, even the irrelevant ones. For example, here is the substring. See, here is the string ABC. These are the characters which we require in the window in order to make a valid window. But what we did here, that even the irrelevant ones like D, O, E, these characters, these kind of characters also we have stored inside our window map. So this is what I am saying, that we have stored the irrelevant characters, and this is where it takes up the space. So this is what we have done, and that is known as the general approach till now, which we have solved. So we have taken all the characters inside our window map, and because of which, what is the space complexity becomes. So for the window map, I can see that the space complexity becomes is the distinct characters. I can see the distinct characters of window or map, window map, or the current window. I can see of current window. Okay, whatever the current window we have, we will be running through, that distinct characters of that current window will be there. Okay, for let us see here that this is the window map, and all the unique characters or the distinct characters in this window map, that is the window map consisting of. And with the help of a general approach, I can see that overall space complexity, what it becomes, it becomes this O of unique characters of T. Okay, let me just write it here, plus this O of distinct characters of this window, of this current window. Okay, so overall, this is the space complexity becomes when we talk about the general approach, when we also store the characters which are not relevant to our solution. Okay, at that point, this is the space complexity we get. But when we talk about the optimized approach, now in this optimized approach, we need not to store all the characters. We only have to store the characters which are relevant to us, which we want in our result, or which are helping us in order to get the minimum window substring. So for that, what we can just do with that optimization, before adding any of the character inside the current window, or before adding and before expanding the window, I can just check that whatever is my s of right, if that is present inside the need map or not. How? Whatever the s of string I am having right now, in order to expand, I will just take the help of this count method again, and I will say that okay, inside this need map, is this s of right available? Means this particular character is present inside the t string or not. If it is present, then only add inside that window map. So if it is present, then you come here and you update this inside the window map with its count. That is how we have to do. So with the help of this condition, we are only adding the characters which are relevant to us. We will not be adding these characters like the characters like O, D, E. These characters will not be there. These will be ignored. So with that help, with the help of that, we will be optimizing the space. So with this condition, we are optimizing that particular space. This is a part of the optimized approach. Okay, so with this optimized approach, what we are saying is that whatever the number of characters, distinct characters are present inside the T string, that will only be coming inside the window map. Okay, so when the unique characters of the T string will be coming inside the window map, so window map will also take the space of that unique characters only which are inside the T string. So again, if we talk about let's just map this. This is for the general approach. Okay, this one. And if I talk about this optimized approach, for this optimized approach, I will be writing here that see need map will be taking the same thing, O of unique characters of the T. But in the case of optimized approach, the window map will be also taking the same thing. That will be the unique characters of T. This is the case in the window map for the optimized approach. So for this, if you try to write this space complexity, then it will be written somewhat like this. When you talk about the space complexity in this optimized approach, that will be a kind of that they are used simultaneously for the need map and the window map as well. So for that, the space complexity will be overall O of unique characters of the T string. Okay, so that will be the space complexity. So this is overall space complexity we have seen, like for the general approach and the optimized approach. For the general approach, the need map is same. It is taking the O of unique characters of T, and for the window map, it takes the distinct characters of the current window when we store the irrelevant characters also. And in the optimized approach, you say that whenever the window that particular character is present in that T string, then only you store inside the window map. So at that point, the space complexity becomes O of unique characters of T, means overall for the need map as well and for the window map as well, because the window map is also storing the characters which are present in the T string. So that is again, it takes the unique characters of T. So both are used simultaneously. Overall, the space complexity becomes O of unique characters of the T. So that is the time complexity and space complexity analysis we have seen in this problem. Okay, so this was the final major problem of the sliding window pattern series, and we started from the simple fixed windows. We then moved to the variable windows, then to the frequency maps, then exactly K tricks, and then counting the subarrays and many more problems. And finally, we have reached a point where we have solved the minimum window substring problem as well, where the logic completely flips and we shrink the shrink when the window becomes valid. So at this point, we should not just be solving the sliding window problems, but we recognize the pattern itself. So now it's time to get to the next major DSA pattern, that is the binary search on answer pattern. And this pattern is much deeper than the normal binary search. We are no longer be searching inside the arrays, but we will be searching inside the answer space itself. So there will be different problems which will be solving based on that particular pattern, and that will be from root to beta to optimal, and along with the time and space complexity analysis. So in the next series, we will just start from the first principles and understand why the brute force works, why it becomes slow, and then naturally derive the binary search on answer step by step. Till then, just keep learning and keep growing. This is Aditya Padaria signing off. Thank you.